That's brilliant. Thanks, Stefan. And thanks for the chance just to be talking a little bit about this great piece of work that we had a chance to go through within Syngenta. Maybe just a tiny fragment of introduction. So I've got a history originally as a chemist working within research, crop protection research, moved into IT a while ago, and I've had a number of roles. I currently head up the content digitization team within crop protection, R&D, IT. Balvinder, I worked with you for a few years, but it'd be better for you to introduce yourself. I don't think I could do you justice.
Thanks, Graham. So I'm the founder of Datavid. Started Datavid in 2018. Before that, I was working for MarkLogic in the UK office as a principal consultant. Many years building. My background is open source, technical architecture, open source, and then for many years I've been using MarkLogic and building products on top of MarkLogic, as well as semantics now most recently, and always interested in solving data problems.
Brilliant. Thanks, Balvinder. So just diving then a little bit into what we're doing, but I suspect many of you won't have heard of Syngenta. So just a tiny bit about Syngenta. So essentially we work with farmers and growers around the world. So we're a leading science-based agri-tech company. The core mission through the different activities that we do is help farmers feed the world, but also help them address the challenges of climate change. So it's not just about more yield, it's about doing things better. It's about healthier soils, healthier crops, healthier people, and a healthier planet. Clearly, to do this, there's a significant research and development activity at the heart of it all. Whether that's the crop protection piece, so that's looking after crops and helping keeping them safe from different pests and diseases that might obliterate them, whether it's coming up with new seed varieties, or increasingly whether it's some of the digital work that goes on within the company. So here's a slightly more cartoony way of getting this across. So some of the crop protection work that we do is about innovating to get different solutions, many of them chemical solutions, to the farmers. The seed innovation that's going on, all of that's a very traditional end of what we've been doing for decades, but always smarter and smarter each year. A couple of the newer areas are biological, so different, often plant extracts that will have the right sort of useful biological effect to help maybe manage a disease. And then things like different Internet of Things, drones for gathering data, precision application to apply things more carefully just where they're needed. All those take increasing amounts of data and applied in more complicated ways to support the innovation that R&D needs. So that's sort of broad brush what the company's about, but what are we trying to do? So if you think about what we must have in the company, it's many years worth of different projects, doing work, and then recording what they've done in reports, current scientists recording what they're doing in various forms, and then bodies outside the company sharing a bit of what they do. All this gives us lots of material that our scientists are trying to tap into, but it's spread across so many different locations that it's hard for them to do that. We've got research information that's tied away in all sorts of formats. So currently the scientists, if they do this, are spending many hours trying to find the information they need. But in some cases, the full challenge is in practice too hard to take on. So they'll only search in a few places for some information. And we've managed to sort of hone this down to sort of two main areas. One is, how do we dig back in time? What one of our colleagues called some digital archaeology. So how do we dig back and find reports from maybe 20 years ago that are relevant to a current research challenge? But also, how might a scientist look across the things that are going on right now, either internally or outside the company, to give useful, very relevant material to help guide a project towards a useful area or away from another one. Lots of this is in documents, so we've got a content searching text analytics challenge here. So the project that we've come up with, we've relatively recently branded Synapse, trying to encapsulate the idea of this being a sort of an application of AI and natural language processing to the more classical enterprise search challenge. So we ingest material, organize it, tag it according to our information patterns and our information models, and then use that to offer up a much richer way of scientists searching across these sources, these different resources. So this is something that we've built. We're not talking about something that we might do in the future. It's got some fairly straightforward things. It's a relatively intuitive search interface. It's got some fairly standard logical operators to support different ways of honing the question that you're trying to ask. We also try and make it as straightforward as possible for a scientist to query this. So if I just go back to that digital archaeology challenge. So as you dig back through time, the identifiers that we use for key things of interest are different. So when you've got a molecule, perhaps that a chemist has made early in research, we just end up giving it just a meaningless identifier, just a string of letters and numbers. But if that turns into the core of a project that might turn into a product that we formulate and market to farmers, it will end up with a trade name. And on the journey between a small thing in research and a big thing being sold on pallets to farmers, it'll go through a number of stages and end up with different identifiers. Any of those could be used in a report to refer to it. So if we treat all of those as synonyms and then tag our ingested documents using that little network of synonyms, then it lets me as a scientist use any one of them to find reports that refer to any of the other ones, trivially. So that use of little fragments of knowledge graph, of synonyms, of information models, and different ontologies and query concepts really helps support the searching that we're trying to do. And then we tie into a few fairly obvious things, but embedded documents. So many of our scientists have got the lovely habit of sometimes having a Word document that has an embedded Excel and an embedded PowerPoint, which might in turn have an embedded Excel or Word document because it was convenient at the time. So we have to be able to deal with that. And the system that Balvinder's helped create for us does just that. And then the ability to move things out of the system where needed, to tie into structured data sources as well, where it's relevant. All a useful part of the material that we're trying to go through. Now, we're getting a bit more technical. I think this is a good point for me to hand over to Balvinder, and he'll talk you through the next few pieces.
Thanks, Graham. So as Graham was explaining, the users have over the years given different identifiers, and how you tag these identifiers from unstructured documents, which could be in Word format, PowerPoint, Excel, molecules, various different formats, going from legacy Word documents to the latest version of Office, which has evolved over the years. So we use natural language processing techniques to identify text tokens from the documents. And to do this, first we have to tag the various concepts and categories using existing knowledge base. So Syngenta already had what we call information model or instance data, which instance data contains all the different variations of a chemical substance, for example, what the molecule was called, what the trade name is now, and all the different variations. So for example, a chemical substance, right? It might have a name now and a trade name by which it is sold, but what are the different identifiers on how you identify the chemical substance, the CAS number, the SIN numbers, the formula of the chemical substance. So we use all those. We describe all those in ontology format, in RDF format. MarkLogic being a 3-in-1 solution, it's also a graph database, search engine, and an XML repository. We can model that RDF data, store it in the database, and then when a document arrives, we tag all this information in the documents, you extract it. And this is where we use entity extraction techniques. Now, there are 2 types of entity extraction techniques we use. One is model based, where you have a model which is already trained, so machine learning model, and it knows how to identify certain patterns and tag them as concepts. And the second type of entity extraction we do is ontology based, which is RDF driven. So we know Syngenta has its own knowledge graph and information about these chemical substance, for example, or crops or products, and we tag them. And the second time is, identifying sections within a document or title of a document or who the author of the document is. So there's the named entity recognition as well. So it's an entity extraction techniques, but a mixture of lot of entity extraction techniques built together in microservices format, which allows to tag all these things, which then users can search using an advanced semantic search user interface. So Graham, if we go to the next slide. So this gives the solution on how Synapse has been built. What you see on the left-hand side are various repositories, external repositories, like we have PubMed, and we have EPA, we have Federal Registry. So various different external repositories where regulatory documents are kept. And then there are internal repositories, which are SharePoint, Documentum, metadata repositories, Viva Vault, shared drives. So all the data, which is in, as the format at the top says, it could be in Word, PDF, images, different formats. All these formats is something we support. And all these repositories, we had to build integration to, sometimes we're calling APIs, sometimes we are sort of scraping the web and getting all this data and information and documents and flowing it through and built an orchestration pipeline, a data flow orchestration engine or a pipeline, which extracts the text, converts it into a standard normalized format, and then we enrich that data, the entity extraction that we talked about. So it's a mix of data hub pattern as well as a microservices pattern, where there are lots of microservices which are being used to do various functions, and the data hub, because we collate so much data from various different repositories into a normalized standard format. And then entity extraction, as I already talked about, named entity recognition part, and model rule-based extraction, as well as ontology-based extraction, and then some semantic disambiguation as well to make sure that something, what's the context of a particular word. So if something is brown or boxer, which is a product of Syngenta, as well as boxer as in somebody who does boxing. So how do you identify, given the context of the sentence, what boxer means in this case? So that's what semantic disambiguation. Once all this data is in the staging database, it goes through the various pipeline where it gets transformed into a normalized format. It gets all the entities are extracted and marked up. Then it reaches the final database of MarkLogic, on top of which we have built APIs, knowledge graph APIs, which allows us to do visualization, as well as search API to do searches. And this is where the multi-model capabilities of MarkLogic have been really helpful in putting all these different formats into one database and providing a richer search experience, semantic search experience to the users. And so this slide is a screenshot of the Synapse user interface. It's a search application. It's a semantic search application built using autocomplete, heavily using autocomplete. So when user starts typing in, the system tries to give autocomplete to say whether, oh, you typed in azoxystrobin, which is a chemical name. Oh, I know this is a chemical substance based on the ontologies that are stored in the system. And then user can do various filters, do and or not, all the standard grammar that is supported, and do a search. And this gives you documents, as well as on the right hand side you see some faceting capability. It also gives some information card about the chemical. It says, okay, these are the different synonyms about this chemical substance. the search result already takes care of finding all documents, even though the word as oxystrobin might not be there. It might be a different name or a different identifier that might have been mentioned in the document. So the synonym search is out of the box, implicit to the user. And then on the right, you also see the chemical substance drawing, the rendering of the chemical, how it looks. We have also integrated some features about drawing the chemical substance. So chemists can come and draw the structure and then say, find me all documents which look like this chemical structure. And that's the draw button on the left top. At the bottom, what you see is the foam tree, which gives you concepts or that are from a particular domain in the ontology model. So chemical substances, right? Within chemical substance, we found 155 concepts across these documents. So user can drill in and then sort of use that foam tree to visualize the results and also filter the documents that they want to, that of their interest to them. This UI also has some sharing capability. On the top right, you see my folders. So there users can, create a folder if they're working on a particular project. They find the documents of their interest, they tag it, and then they can share the folders with other users. And what you see on the right is some new things that we are trying, new visualization. This is still very much being tried out, where it uses clustering algorithm to cluster documents which have similar words or phrases in it. And this is something still under development. We are exploring how the users would want to use it.
Brilliant. Thanks, Balvinder. So just picking up on that last point. So yeah, this has been a bit of anything from a sort of an early proof of concept through to a bit of piloting to where we are now, which is soft launching into our R&D community for some time. But we're still very much up for exploring things with the scientists. This isn't just a trivial case of, we wrote down what we needed to do 2 years ago and now we're just cracking on with delivering it. This is a sort of more complicated area where we're trying to help the scientists work out how to work with large numbers of hits and work with documents from across different points in time and different sources. Hence the interest in exploring different visualizations. So then maybe just to wrap up, where are we at? So we were setting out just to support innovation. So that's the ability maybe to join things up across different disciplines, across different parts of our R&D function, or sometimes across from external parties, external literature, whether academic or other bodies, into the R&D teams within Syngenta. So we've got through Synapse a platform that supports that. It's got millions of documents ingested, tagged, and available to this growing team that we've soft launched to, and they're already making use of it. So they're still helping us work out some tweaks that we need to make to the platform. Inevitably, with something like this that's crossing over so many information sources, we've hit some difficulties, some bumps along the road. Every now and again, we've realized, oh dear, we're going to have to go back and re-tag everything that we've ingested because we've needed to radically change some of our architecture. And we've had to slog through doing all of that. But it's taught us things about how to do that efficiently. So we've got something that is helping with individual searches. So each of those is faster than a typical legacy system would be searching. And it's searching across different silos of information. So it's much more comprehensive. The way that we can hop across different synonyms and other parts of a knowledge graph means that we can tie concepts together and therefore tie results together to give a much richer and more useful set of answers. Scientists are now doing things that they simply wouldn't have done before because it was too hard. They wouldn't spend a week doing a complicated set of searches because they just wouldn't be able to spend the time. They can spend an hour using Synapse to get some really useful things back. And how do we know that this is working? Well, probably the best example I've got is Syngenta quite a few months ago ran within research a little different thing, a digital innovation research project. So not an IT thing, but a piece of science R&D, but trying to tap into data. And the team wanted to dig back in time and find reports from 30 years ago or 20 years ago that might help. They did. It was quite hard work, and Balvinder and the team put quite a bit of effort into working with and bridging across some gaps in this system. But it gave the scientists some real results. They found something that was there in reports from quite a few years ago that had been parked, that gave some real innovative ideas to a project. It really helped accelerate that project. And in the last couple of weeks, that whole exercise has won Syngenta's internal science and technology prize. It's a clear recognition that this whole approach is really valuable to the scientists in R&D. So happy to take questions via chat and later on, but I'll thank you for your attention and the chance to share this with you.